Hi guys, we're back for another edition of Meteorology Lab, and we've got a bunch of cirrus out there. You can see it spreading in there from the north. We're going to take a look at why that cirrus is in the area. Had a little bit of a late start because been pretty busy with programming, and that kind of puts me on an unusual schedule there. So there's a little bit of the work I'm doing, trying to get digital atmosphere done, and that is, to say the least, very mentally fatiguing doing maintaining a program this big. But I'm getting there, and I'm going to be making some progress with that tonight. And then a quick look outside. Let's check out the outside cam. And the light is gradually fading there. So that brings us to the cirrus and the upper level charts. So let me bring up the... Yeah, here we go. We can see we've got a little bit of a pattern shift here. We got a cold front coming south from the Midwest, and there it is, and cold air advection coming back in behind that, and just behind the frontal boundary looks like a little bit of scattered thunderstorm activity. Got some more organized storms in the Memphis area out of the southeast U.S. Pretty quiet today, and then let's see if we can go up to the northeast. We don't often make it up into that part of the country. So here it is, gradually coming up. At least I think it is. Well, while that's working, we'll just continue on and look at the SPC chart, and it looks like we've got a slight risk out there for the Nebraska Panhandle. And you can see how this is kind of shaped around the leading edge of that cold front that's working southward. 500 millibar chart, and we're looking at anomalies. So we can bring that up to the current chart, and you can see that the Hudson Bay vortex kind of broke down a little bit over the past week, but it looks like it's starting to get steam again. And there it is. We've got heights at 500 millibars and higher below normal in that area of the western high or the eastern high Arctic. And a little bit of ridging over the Canadian prairies, so with that ridging there, that's helping to bring polar air masses southward. Okay, just a quick look at the 250 millibar chart from the Canadian Environment Canada. And this shows a bit of that 500 millibar ridge right there, or the 200 millibar ridge. And then you can see we've got high pressure across the plains. There's a close look at that, and this is a chart for this morning, so it looks like the center of that high pressure area, maybe one little center over Wichita, maybe another center out over northeastern New Mexico. So that puts Texas underneath this easterly flow, so we got 40 knots and a little bit of a weak jet coming in from the northeast there. There's a look at that on the UCAR upper air charts, and that shows pretty much the center of the high where we identified it earlier, and you can see a bit of that jet stream wind actually making it from Atlanta down to New Orleans, and then another piece of that in Texas. So if we're able to get any storms, that will definitely help enhance them. 500 millibar charts showing kind of a weaker pattern across Texas. Also at 700 millibars, weak winds. So that gives us enough upper level shear to help organize the storms, but we're not going to get the kind of curved photographs that we need for severe weather in this part of Texas, or actually anywhere in Texas for that matter. So let's head straight to the satellite images, and there it is. You can see the leading edge of that front pretty much all the way from Kentucky across Arkansas and Oklahoma. North of that, some fairly clear skies. We can see cloud streaks coming from the northeast. So that's that dry, mild flow heading south. And then down to the south we can see a little bit of that sea breeze working inland into Texas, but looks fairly suppressed. Very little convection going up along that sea breeze. So we've probably got a little bit of capping in place. But where we do have convection, you can see those long streamers, like this one cell right there near Beaumont, and also out in the Florida Panhandle, looks like a 200-mile long Anvil stream right there. Here's the infrared imagery. We don't often show this, but it does show you kind of like the banded appearance ahead of that front coming out of the Great Lakes. And the monsoon also pretty active there in Arizona and New Mexico. Not quite as active as what we had earlier in the week up in the northern Rockies. And here's the water vapor imagery. We've got an abundance of water vapor all through the U.S., even into the Midwest right there. Looks like a little bit of a dry incursion into West Texas. Maybe we'll take a look at the Midland sounding. And then as you go further north, you get more into the frontal type weather regimes, the prevailing westerlies. Now for the tropical segment, it's going to be kind of abbreviated today since I've been kind of overloaded here, but we can check out India, and we can see the monsoon flow is in full effect. Got pretty much cumulus layers all the way up the Ganges River Delta, and the Ganges River that pretty much extends like that. Himalayas located right there, and this is the reason why they can't do climbing like of Mount Everest in June and July, because of the incursion of the monsoon northward, which means storms go up very early in the morning on the mountain slopes there. So if you go and climb Mount Everest, you're going to get caught in pretty much blizzard conditions up at that level. You're pretty much up there in the side of a thunderstorm, I guess you could say. So very hazardous, and that's the reason they try to hit Mount Everest climbing in late April and early to mid-May, and then the season shuts down there. And we see some sort of cyclone right there. There's a little bit of a monsoon cyclone. I don't know if we can get much of a look at that, but this is kind of like a mesoscale convective vortex. And we can probably see that a little bit in the data. There's a low pressure area right there, pretty much corresponding to where that low is. And I thought I had another chart queued up. Okay, I guess I don't. We'll check that out later. Excuse me a second. You can see the very high precipitable water there in India. We have amounts up to 2.5 to 3 inches, and we don't often see it that high here in Texas. But the moisture pretty much banked up against the Himalayas right there, all the way to the higher elevations of Pakistan and Afghanistan there. So basically monsoon season full effect, and you can also see the monsoon trough. Let me see if I can zoom that in a little bit. This is kind of tied to the very intense surface heating. There's low pressure right there, and all of this right here, this is a trough. So the patterns here are pretty much dominated by high pressure over the oceans and the circulation flowing inland to where there's the intense heating, and that's basically the monsoon flow there. And then right there along that trough we get a large area of synoptic scale ascent And with all the moisture flowing into India there, that means a lot of widespread thunderstorm activity. So that's a pattern that gets going in May, June, and July there. So we're pretty much deep into monsoon season. Where we're at, let's see here, I've overlaid the dust. We're looking at the Atlantic. There's the African coast here. There's South America and then North America like that. So a little bit of that dust has made it up into Florida, Georgia, Mississippi. Maybe a tail end part of that in Texas, just a little bit of that. A little bit of dust going through central Atlantic Ocean, and a little coming off the African coast. Obviously, it looks like there's not a whole lot of dust transiting the Atlantic right now. A couple of, maybe one little easterly wave right there. Other than that, the Atlantic looks pretty clear. But we're looking things to get active probably here in the next few weeks, with sea surface temperatures being quite a bit above normal. Okay, just a quick look at the fronts here. Now you might think I might be looking for low pressures and troughs. For example, maybe a trough there, low pressure here. But actually it's the high pressure areas that drive everything, especially when the patterns are in a northerly flow situation like what we have here. So we've got a high right there over Ontario. So basically this is a big dome of cold air moving southward into the Great Lakes area. So from that it's pretty easy to find where the fronts are. The fronts are just going to go kind of around the periphery of that high. So fronts coming into Oklahoma, Kentucky, Pennsylvania, and New York, and kind of a backdoor front there in Wyoming and Montana, and a little bit of that lift in that upper level, that upslope flow in the higher elevations. That's helping to produce thunderstorm activity there in Nebraska and Wyoming. So that explains why we've got those slight risk areas for that part of the country. It's that upslope flow and enhanced ascent associated with that backdoor front there. And then we've got probably a little bit of a Pacific system perhaps in place, something like that. And then we get into another polar air mass out over the Gulf of Alaska. Quite a bit of polar air across the Canadian high Arctic, and we see a large blob of cold air right there. So that could be the start of the next front. Maybe about to head southward here shortly. So this is kind of like a pattern we might see in August and September, and it's hard to believe just one more month and we'll be starting to look at fall here. So there's the next system, and we've probably got a little bit of a westerly and northwesterly flow, so that may bring this southeastward over the next several days. Okay, we're going to look at soundings, and I remember I was going to look at Midland because they had a lot of dry air according to the water vapor imagery. And you can see it right there, up above 10,000 feet. And you can see the strong winds up at 20,000, 30,000 feet. However, there is a lack of low-level moisture. We do have dew points there in the low 60s, but the moisture does fall off with height fairly steadily. So by the time you're up to about 10,000 feet, dew points are in the 20s. So that means as surface heating commences, as we get the sun beating down and we start mixing the air, some of that dry air starts working to the surface, some of the moisture works aloft, and we end up averaging out the columns. So basically we have a dew point of about maybe 50, lower to mid-50s, and so you mix that with 100-degree temperatures, and it's going to be very hard to get lifted parcels there. A lot of capping. Let's see what went wrong on the Gulf Coast. Not much thunderstorm activity. Looks like the culprit is dry air aloft. So it looks like even down in the Texas Gulf Coast, that's a problem right there. Now that's just a hunch, and to really figure that out we need to take a look at the surface charts, because if that is the case we're going to see a decline in the dew points. So let's see what dew points are looking like in that area. Well, let's see, we do have 60s around Austin. That's pretty depressed, but dew points hanging on there in Lake Charles. Okay, so there may be other reasons why we're not getting convection. So let me go back to that chart. Well, the other culprit, look at that warm air there, 900 to 800 millibars. So if we get heating, it's going to be just a little bit of capping there. So that's probably enough to shut down convection, because obviously we're not realizing this kind of cape that the soundings are showing. And there's a definite reason for that, and it's going to have to either be due to dry air reaching the surface and mixing with the parcels, or it's got to be due to the capping here. It's going to be one or the other. And this, from what I'm seeing here, that's probably the most likely reason. Maybe a little bit of subsidence, perhaps even helping to build that. Let me see if I can bring up the current sounding there at Lake Charles. Okay, so let's see here. We've seen the conditions warm up here at Lake Charles, and let's see if we try to lift a parcel, maybe lift the lowest 100 millibars. We are just barely capped there, and I think maybe just a little bit more heating might have allowed them to get going. So there is some instability there, but as we've seen on the satellite data, just nothing going on there. So these are some of the mysteries you have to kind of work with as you forecast weather across a region. You're going to have problems like this you're going to have to try to solve, and sometimes, as I've shown you, you have to use the process of elimination to kind of figure out what might be happening. Upper level dynamics looking like this. 500 millibar chart, not showing that upper level high quite as much. What we're seeing here is more northwesterly flow, and looks like a couple of good waves coming through Minnesota right there into the Great Lakes. And let's see where that ends up tomorrow. There's the 6 a.m. And then by the time we do the webcast tomorrow, that wave is going to be moving down into Ohio, Pennsylvania, and Kentucky, West Virginia, coming up on those areas, and then ridging back in behind that. And this ridging, this looks to be like a frontal ridge, so this is probably supporting an upper level high or some anti-cyclogenesis over Ontario. So we're going to watch for that on the charts there. Northerly flow in Texas, that's going to mean some of the cold air probably is going to make it southward into this area. And towards the end of the period, 60 to 72 hours, it's pretty much solid northerly across the central U.S. All right, just a quick look at the mesoscale forecast, and we're going to look at the Ohio Valley overnight. Convection pretty much shuts down. If you cells do keep going in Tennessee, maybe a little bit of inflow feeding those storms there. And those move into northern Alabama, Huntsville, and maybe to Atlanta early tomorrow morning. And then we see storms start to regenerate out over the Appalachians, but as you go further north, you get more into that dry air. This is all cold air advection, and the leading edge of the front probably something like that right there. And then the synoptic scale picture, I decided to bring up precipitable water. We haven't looked at this too much. But let's get an idea of what the water vapor in the atmosphere is doing. Most of the higher precipitable water concentrated across Missouri and Illinois ahead of that cold front. And then we see that get pushed southward ahead of the front and down into Louisiana and Texas. So I think we're going to see precip chances going up around the weekend. And you can see that dry air making it into Indiana, Ohio, and Illinois. And then we have a frontal system moving off the Atlantic coast. And there it is, low pressure right there near New York on Saturday night. And then it goes up into, looks like maybe one wave working up towards the Canadian Maritimes, and then some redevelopment down along the North Carolina coast on Sunday night. But man, look at all that cold air, that dry air, I should say dry air, filtering southward, mild dry air all the way to Texas and all the way to the Gulf Coast. So pretty much everywhere east of the High Plains is going to be under the influence of that unseasonably early mild air push that comes southward. Then the moisture comes back up later in the week, next Thursday and Friday. And there it is. We see 2.5-inch totals across Texas and Louisiana. So I think we're going to have rain in the forecast around the 3rd or 4th. Generally this time of year, when you have precipitable water that high, that's a good sign that at least you're going to be running 30 to 40% precip probabilities. And then some of that makes it into the southern U.S. And then we have the next push of cool air coming southward, not quite as strong. In fact, we get a bit of a tropical surge northward around the 10th and 11th. And then we get to the end of the run, and it looks like some sort of tropical storm coming on shore in Texas around the 11th or 12th. You see that right there? And then you have this almost 3-inch total across New Orleans. So something is going on right here. It looks like maybe some sort of wave. Let me backtrack that. So you see that right there in the Western Gulf. And the origin of that looks like maybe some easterly wave. So the origin is definitely in the Caribbean and the deep tropics. So this is August 5th, so this is kind of a ways off. But you can see that we've got kind of like the tropical easterlies affecting this entire area. So that puts Texas and the southern U.S. underneath this expressway. Sorry, I realized you probably can't see what's going on. Okay, let me show you that one more time. Yeah, right here. This is around the 10th. You see all the isobars kind of stacked up like this. And that's a pattern that's going to bring tropical weather pretty much straight inland into the Gulf Coast area. So we're going to be looking at those easterly waves working their way up into the Gulf and into the Texas and Louisiana area around the first or second week of August. All right, been going on quite a bit here. Let me take a look at chat here. We've got Sue M here and Justin and Ryan. David says, typical hot summer day in the Metroplex today. Ron Chalfant is here. Ryan Toomey says 102-degree heat index in Florida. Inland storms over the Everglades. Ryan sent an email, and I'm kind of behind on the emails too, so I'll check that out. Kevin McKinney, Mike Estwick joining us. Sue M. keeps seeing a weird red line under the video window. Can't quite explain that. Eric Hall is here. Mike Estwick. Happy birthday to Mike Estwick. Hopefully that birthday number is not too high. Michael Burrell here. And Sue M says audio is skipping earlier. Large typhoon about to make direct strike landfall into Taiwan. Yeah, I had that on another chart. Let me see if I can bring that up. Typhoon out in Asia. Yeah, here it is. Let me check my preview window. Pretty much northwest of, or northeast of the island of Luzon, Philippines. And normally the typhoons kind of take a west-northwest to northwest track. So it looks like here maybe Taiwan and Hong Kong, located right there under the gun. Let's see what the GFS does with this hurricane or typhoon. I mean, it's basically a hurricane. Typhoon moving pretty much right towards Taiwan, and then onto the coast right there of China. And you can see the very high precipitable water. Flooding is usually a big problem with these storms when they make landfall. You can see that the coastline of Asia shaped a lot differently from what we have here in the U.S. So when these storms move inland and start to recurve, they're pretty much well over the land areas. So you end up with widespread precip activity there in China, and the storms there can be just absolutely devastating. So there goes the remains of that system, and you can see 2.5 to 3 inch precipitable water. Looks like a pretty good hurricane, or there I go again, typhoon, south of Japan right here. And I don't know how well the GFS handles these tropical systems. I mean, obviously the GFS is a global scale model. So I may have to look around and see exactly how these models parameterize these hurricanes. But wow, look at all those lines right there on that system. And I think that's near Iwo Jima. Now that looks like an impressive storm there, and that looks like it recurves and pretty much avoids Japan. But, you know, this is 250 hours out, so who knows. One interesting chart that I had, by the way, is precipitable water anomaly. Let me see if I can bring that up here. Yeah, here's precipitable water anomaly. So areas that are green are running above normal, and you can see India just a little bit above normal, but definitely there in Pakistan, very unusually high normals, and you can see the elevated values around these tropical systems. It looks like another one off Hong Kong right there. And there we go. You can kind of see the cyclonic movement. So yeah, definitely a tropical storm there. Tropical system off Hong Kong. And there goes that other system into Taiwan, and then this other huge system there near Iwo Jima. And I believe I brought one of these charts up for here in the U.S. If I can find it. There it is, precipitable water anomaly for the U.S. So you can see the Midwest in the Ohio Valley running way above normal. So what I wanted to do is bring up a sounding for that area. Wow, we don't have any soundings like right around Paducah. That's really bad. We're almost completely dependent on Nashville. Well, Nashville looking like this here. However, you know what we can do is we can put a We can put the cursor over the Ohio River Valley like this. Just click on it. Oh, is that not working? I thought that would bring up a forecast sounding there. I guess it's not enabled here on these GFS runs. But anyway, much above normal there in Illinois, so no wonder we're getting widespread precip in that area. So let's just check out the pattern. You can see the push of very dry air into the Midwest. So there's a dry anomaly coming down south through the Mississippi River Valley all the way to Texas. So wow, you can really see it here using this product, and you can pretty much see that it makes good headway off the Gulf Coast, way past New Orleans and all the way to Corpus Christi and into central Texas right there. So to a certain extent, you can kind of find where the limits of the cold front are and maybe find the boundaries. So here comes a surge of tropical air coming back. High values over Texas. Where did this come from? Kind of looks like some of the origin might be from inland, but anyway, there's higher values also. These are the waves opening up, and you can see the flow from the tropics. Let me move this. So there it is. You can see one surge right here around Yucatan on the 5th, another one lining up, and looks like they're going to take aim right there on Texas. So you can basically time this and figure out when we're going to be looking at major precip events. Okay, then just a quick look at the upper air patterns. Pretty much a big high over Oklahoma and Kansas. And just over the next few days, we're going to see that stay in place, 30th, 31st, and then it'll start backing off into the Big Bend area. We start coming under this northwesterly flow. So with northwesterly flow and these waves moving through the flow, I think we're going to be looking at MCSs starting to affect Texas, Oklahoma, Kansas, northwesterly flow MCSs. And this pattern is really starting to bear a resemblance to August of '96. And that was a cool year for the Great Lakes. And we had a lot of MCS activity in Colorado, the High Plains in August, and they were moving southeastward every night almost. So I think we may be getting into a pattern like that here soon. And we'll just take a quick look here at the sea level pressure. And then we'll wrap it up here. So there's the high pressure area out over the Great Lakes, and you can kind of see it covering the Midwest. And there comes the front southward around the 31st and 1st. And looks like some storms get going there in the high plains. You can see upslope flow in Texas. Kind of an easterly gradient there. And yeah, the model is hinting at northwesterly flow storms there affecting Texas. And then towards the end of the run, 5th, 6th, 7th, we start seeing the tropics opening up. And there come a couple waves into Texas right there. And once again, high pressure covering the Great Lakes. Unseasonably mild and dry pattern there for that part of the country. Okay, just one last look here at chat. Ryan mentioning emergency declaration there in Taiwan. Anyone who's curious, check out the NHC site. Ryan there watching the Taiwan news outlet about the incoming storm. And yeah, you can definitely check that out on the internet there. So hopefully they things aren't working too bad. But flash flooding, of course, that will be a big issue, and especially Taiwan, very rocky island, also prone to landslides and that kind of thing. All right, I think I'm pretty much done here. I've kind of went on for quite a while, so 40 minutes in. Anyway, I appreciate y'all watching the webcast, and I think that'll do it for me. Hope y'all have a good evening, and we'll see you tomorrow.